Okay, and I'm back for part two. Part two will be much shorter. There's only one part left to do. So what I found out is I had accidentally set to stream instead of record. So I had to retrieve the first part. This is what happens when I do it tired, but that's okay. I want to move on to example 2.8, which is way shorter because there's fewer cases. Oh, by the way, for the previous one, example 2.7, the book does the entire drawing of everything probably way better than what I can do by mouse. So definitely take a look at the book's drawing. But the book's got this. This is example 2.8. I wonder if the tablet will start working again. We'll see. It's just way easier to write this way. It's just the mouse was neater for drawing straight lines. E to the 2t u of negative t, and the impulse response h of t. There we go, back to the random lines. Is u of t minus 3. Okay, well, let's again start by drawing x. U of negative t means it only exists for negative t. So if this is tau, this is 0. We've got a thing that looks like this. Nope, I gotta do this by mouse. That's 1. Here is my x of tau. And h of t minus tau then? Here's tau, height of 1. That is a straight line. I don't know why it jumps around so much when I use my tablet. It's an old tablet though. I'll go back to using mouse, t minus 3. Okay. So for any value of t, doesn't matter what little t is, there are going to be regions of overlap between these. So this is if t minus 3 is less than 0. Let me write. This is h of t minus tau if t minus 3 less than 0. And then other case over here, if t minus 3 is greater than 0. Minus, so here's tau. So this is if t minus 3 is greater than 0. And again, this is h of, well, that's an awful 0 up there. T minus tau. Now the nice thing is we can see here, these are the only two cases because x only exists from 0 towards negative infinity to the left, and h of t minus tau extends infinitely to the left. That means there's always going to be overlap. We don't have to have any of those cases of there's no overlap, there's zeros. So we have only these two cases. So basically, the first case is going to be all of x because where's my cursor? All of x is to the left here, so it covers all it. The second case is going to be at t minus 3 here. Just this part of x. Which is nice because it's the same equation either way. So let's just make it, instead of t minus 3 and, where's my cursor? I keep losing my cursor here. So this is, we can also write this as, let's say less than or equal to 0 here. T less than or equal to 3 and t greater than 3. Okay. The nice thing is it's the same integral, just different different bounds. So I'll have to scroll up for this. So let's look at the first case where t less than or equal to 3. So we're talking about from negative infinity until t minus 3. So y of t is the integral negative infinity to t minus 3 of the equation, which is e to the 2 tau d tau that's fortunately easy enough to do. 1/2 e to the 2 tau from negative infinity t minus 3, which might seem nasty that we've got negative infinity, but because it's e to the negative infinity is 0. So this is 1/2 e to the 2 parenthesis t minus 3 minus 0. So just that part. Now for t greater than 3, just different bounds on our integral. Now we have all of x, so from negative infinity all the way up to 0, which is going to end up being an even simpler equation. Same integral, 2 tau d tau. So 1/2 e to the 2 tau from negative infinity to 0. The negative infinity is still going to be the same. It's going to have a minus 0. When tau is 0, e to the 0 is 1, so that's just 1/2. So all that's left here is y of t is this equation, 1/2 e to the 2 parenthesis t minus 3 for t less than or equal to 3 and equal to just 1/2 for t greater than 3. That was way faster than the last one, wasn't it? Well, the last one, a lot of the time was spent just working at the foiling and geometry. So I'm going to go ahead and end the recording in just a moment. There should be in Canvas discussion forums. I hope they work. I will be posting this video and the previous video on YouTube and put links on Canvas. So hopefully have a good day. Feel free to post on the discussion board with questions, and hopefully I will see you guys in class on Thursday.